Welcome to VERTEX, the place where we follow the real data behind the strangest events in our universe, from interstellar visitors to missions that could change humanity's future. If you're ready to look past comfortable answers and face what the numbers are actually telling us, you're in the right place. What if something from beyond our solar system isn't just passing through, but arriving, not drifting, not tumbling on some random path shaped by billions of years of cosmic chaos, but moving toward Jupiter with a level of precision that, according to the laws of probability, shouldn't happen by accident? The kind of precision that makes scientists stop talking, lean forward in their chairs, and whisper a question nobody wants to ask out loud. What if this isn't natural? This isn't about objects floating past planets. This is about something threading a needle across billions of kilometers, hitting a target so specific that even calling it luck feels like ignoring what the data is screaming at us. Stay with me for the next several minutes, because what we're about to examine isn't speculation dressed up as science. We're going to walk through real data from NASA's Jet Propulsion Laboratory. Calculations verified by observatories around the world have divided the scientific community between those who prefer comfortable explanations and those willing to ask uncomfortable questions. We're going to look at an object called 3I Atlas, and specifically what it's doing right now, heading toward Jupiter's gravitational sphere of influence with a precision that defies the chaos we expect from random celestial mechanics. Here's what makes this situation extraordinary. Jupiter has what astronomers call a hill radius, essentially a gravitational boundary, a sphere of influence where Jupiter's gravity dominates over the Sun's pole. For Jupiter, that boundary sits at a very specific distance from the planet's center. When scientists calculated where 3I Atlas would be on March 16, 2026, based on its current trajectory and the measured changes in its velocity, they discovered something unsettling. The object's minimum distance from Jupiter matches the hill radius within margins so tight that the odds of it happening by chance are roughly 1 inch, 26,000. Think about that for a moment. This isn't close or in the general neighborhood. This is threading a needle across billions of km of space. Avi, the Harvard astrophysicist who has built a career on asking the questions other scientists avoid, looked at these numbers and didn't see a coincidence. He saw a pattern that demanded explanation. When NASA held a briefing in November 2025 to present findings from 8 different space missions observing 3I Atlas, the tone was reassuring, almost dismissive. Yes, the object was interesting. Yes, it had some unusual characteristics, but fundamentally, the message was clear. This is a comet. Nothing extraordinary. Move along. Loeb's response was swift and pointed. He accused the agency of minimizing the anomalies, of lowering expectations, rather than raising the quality of investigation. His criticism wasn't based on conspiracy thinking or attention-seeking. It was rooted in the same data NASA was presenting, but viewed through a lens that refused to ignore uncomfortable implications. The tension here isn't just about one scientist disagreeing with an institution. It's about a fundamental divide in how we approach the unknown. On one side, there's the conservative position. Assume natural explanations until absolutely forced to consider alternatives. On the other side, there's the position Loeb represents. Investigate anomalies without preconceptions. Follow the data wherever it leads, even if it leads somewhere that makes us uncomfortable. Both approaches have merit. Both have historical precedent. But when you're looking at an object that appears to be arriving at a gravitationally significant location with precision that strains natural explanation, the question isn't which approach is more comfortable. The question is which approach is more honest. What makes March 2026 more than just another date on the calendar is that we're not talking about distant speculation. This is happening right now, unfolding in real time, and we have less than 2 years before the predicted arrival. If 3I Atlas reaches Jupiter's Hill radius exactly as calculated, we face a moment of scientific reckoning. Either we're witnessing a coincidence of staggering improbability, or we're witnessing something that requires us to expand our understanding of what's possible in our solar system. The comfortable answer is that comets can do strange things, that orbital mechanics are complex, and that unusual outcomes sometimes emerge from natural processes. The uncomfortable answer is that precision suggests purpose, that mathematical exactitude at this scale might indicate intention rather than accident. The stakes go beyond academic debate. If an interstellar object is demonstrating controlled trajectory adjustment, if it's not just falling through space, but navigating through space, then every assumption we hold about our cosmic isolation comes into question. We've spent decades searching for signals from distant civilizations, pointing radio telescopes at faraway stars, analyzing light from exoplanets for biosignatures. Meanwhile, according to the data Loeb is highlighting, something might be conducting a close-range investigation of the largest planet in our solar system, and doing so with the kind of precision that suggests advanced planning. The counter-argument is always available, always reasonable. Natural processes can mimic intentionality. Comets come out unevenly as they warm, creating thrust that alters their paths. Gravitational interactions are complex and can produce surprising outcomes. The universe is vast enough and old enough that even unlikely events eventually occur. These points aren't wrong. They're just not sufficient to explain why this particular object coming from interstellar space would undergo course changes that place it at a gravitationally meaningful location with precision that exceeds what we'd expect from random processes. When you add up all the factors, the timing of the trajectory change, the location where it occurred, and the exact magnitude needed to reach Jupiter's Hill radius, the natural explanation doesn't get stronger, it gets more strained. What Loeb is asking isn't unreasonable. He's asking for an investigation that matches the scale of the anomaly. He's asking for systematic observation instead of opportunistic snapshots. He's asking for the kind of scientific attention we demand if we detected a radio signal from space that showed structured patterns. The response he's received has been mixed. Some researchers share his concern that we're not taking this seriously enough. Others dismiss his interpretation as premature, a leap toward extraordinary conclusions without exhausting ordinary possibilities. Both groups are working from the same data, seeing the same numbers, looking at the same trajectory plots. The difference is in what they're willing to consider. This is where you come in, not as a passive audience, but as fellow investigators. Science isn't just something that happens in universities and government agencies. It happens when people pay attention, ask questions, demand rigor, and refuse to accept explanations that don't quite fit. The data about 3I Atlas is public. The calculations are available. The predictions are testable. March 2026 will arrive whether we're paying attention or not. And when it does, we'll see whether this object behaves as predicted. If it reaches Jupiter's Hill radius exactly as calculated, that's evidence that demands a response. If it doesn't, that tells us something, too. Either way, what we're witnessing right now is the unfolding of a natural experiment with implications that reach beyond astronomy into questions about our place in the universe. So, here's what I'm asking. Share your perspective. Bring your skepticism. Bring your theories. Bring your calculations if you have them. This isn't about choosing sides between NASA and Loeb. It's about engaging with data that won't go away just because it makes us uncomfortable. Comment below with your thoughts on what's happening here. Not what you want to be true, but what you think the evidence actually suggests. Hit the like button if you believe this deserves more attention than it's getting, more investigation than it's receiving. And if you're someone who understands that the most important scientific moments often come when we're forced to question our assumptions, then subscribe and turn on notifications. Because what happens in March 2026 might be one of those moments. We, the curious, need to keep watching this, keep questioning this, keep demanding that the investigation match the scale of what we're seeing. The numbers are in the table. The calculations are verifiable. The prediction is testable. Now, we wait, we watch, and we see whether the universe is about to show us something we weren't prepared to find. But waiting doesn't mean passive acceptance of whichever narrative feels most comfortable. It means active engagement with the possibility that we're witnessing something unprecedented, something that requires us to expand our thinking about what moves through our solar system and why. The assertion that 3I Atlas is heading toward Jupiter with impossible precision isn't hyperbole, it's mathematics. But to understand just how impossible this precision actually is, we need to look at the specific numbers that have scientists divided. The calculations that turned a curious observation into a controversy that won't disappear. When astronomers talk about Jupiter's Hill radius, they're describing something both simple and profound, a boundary in space where Jupiter's gravitational influence becomes stronger than the Sun's. It's not a physical barrier you could see or touch. It's a mathematical threshold, a sphere of dominance that extends outward from Jupiter in all directions. For an object approaching Jupiter, crossing into the Hill radius means entering territory where Jupiter, not the Sun, controls what happens next. The radius for Jupiter, given its massive size and distance from the Sun, sits at approximately 5,312 million kilometers from the planet's center. This isn't a round number chosen for convenience. It emerges from equations that balance gravitational forces, orbital mechanics, and the specific parameters of Jupiter's situation in the solar system. Now, here's where the situation with 3I Atlas becomes difficult to explain away with casual dismissals. Using data from the Jet Propulsion Laboratory's Small Body Database, incorporating observations from more than 230 observatories worldwide, scientists calculated the predicted trajectory of 3I Atlas with the kind of precision modern astronomy has made routine. They factored in the object's velocity, its observed changes in acceleration, the gravitational influences from the Sun and planets, and every measurable variable that affects how objects move through space. The result of these calculations showed that on March 16, 2026, 3I Atlas would reach its closest approach to Jupiter at a distance of 445 million kilometers from the planet's center. Read those numbers again. The predicted minimum distance for the 3I Atlas is 53.445 million kilometers. The difference between these two values is less than 60,000 kilometers. In the context of interplanetary distances, this is nothing. It's not even a rounding error. It's precision that suggests targeting rather than coincidence. When you calculate the margin of error here, you're looking at a match within roughly 1 part in 1,0,0. But the full picture is actually more striking than that initial comparison suggests when you account for the range of possible trajectories that a randomly moving interstellar object could take. When you factor in all the variables that could push it higher or lower relative to Jupiter's gravitational sphere, the probability of landing this close to the Hill radius by pure chance drops to approximately 1 inch 26,000. Let that settle in your mind for a moment. Imagine throwing a dart at a target the size of the solar system and hitting a bullseye the width of Jupiter's gravitational boundary. Imagine doing it not from across a room, but from across interstellar space, starting your throw from a point beyond the orbit of Neptune. Imagine that your dart somehow corrects its flight mid-journey so that it arrives at exactly the location that matters most from a gravitational perspective. This is what the numbers are telling us happened with 3I Atlas. Either we're witnessing probability defying itself, or we're witnessing something that chose this destination with purpose. The trajectory data becomes even more interesting when you look at how 3I Atlas got to this precision. The object didn't simply fall toward Jupiter on a straight line. It underwent measurable acceleration that wasn't caused by gravity alone. This is documented in the JPL data, a clear indication of what astronomers call non-gravitational acceleration, meaning forces other than gravity were changing the object's velocity. For typical comets, this happens when ice on the surface heats up and vaporizes, creating jets of gas that push against the comet like tiny rocket engines. It's a well-understood natural process that explains why comets don't always follow purely gravitational paths. But here's what makes 3I Atlas different. The magnitude and timing of its acceleration were exactly what would be needed to shift its trajectory from wherever it was originally heading to a path that intersects Jupiter's hill radius with the precision we're discussing. Think about what that means. If the non-gravitational acceleration had been slightly stronger or slightly weaker, 3I Atlas would miss the hill radius by millions of kilometers. If the acceleration had occurred at a different point in the orbit, the effect on the final trajectory would have been completely different. But instead, the acceleration happened at the right time, with the right strength in the right direction, to produce an arrival at Jupiter's gravitational boundary that matches calculated predictions within margins. That's strain, natural explanation. It's not just that the numbers align, it's that they align in multiple dimensions simultaneously. Distance, timing, velocity, and direction all converge on a single outcome that just happens to be the most gravitationally significant location relative to Jupiter. Loeb's analysis of this situation doesn't claim certainty. It claims that when you see this level of precision in natural systems, you demand extraordinary evidence for the natural explanation, not just comfortable assumptions. The standard response from more conservative astronomers is that comets are unpredictable, that outgassing can produce surprising results, and that we don't fully understand all the factors influencing interstellar objects. All of this is true, but none of it explains why the unpredictability would resolve itself into such exact precision. If comets are chaotic and unpredictable, we'd expect their trajectories to scatter across a wide range of possible outcomes. We wouldn't expect them to converge on gravitationally meaningful targets with accuracy that suggests measurement and adjustment. The mathematics here aren't in dispute. NASA's own data confirms the trajectory. JPL's calculations are based on the same orbital mechanics that successfully guide spacecraft across the solar system with pinpoint accuracy. The observatory's contribution to this analysis represents some of the most sophisticated astronomical instruments humanity has built. When this much technical capability points toward the same conclusion about where an object is heading and when it will get there, dismissing the implications requires more than saying, comets do weird things. It requires explaining how this particular weird thing happened to produce results that look identical to what we'd expect from deliberate navigation. The most conservative interpretation is that we simply got lucky, that a random combination of forces pushed 3I Atlas into a trajectory that just happens to align with a gravitational target whose significance is undeniable. But the problem with invoking luck at this scale is that it isn't an explanation. It's an absence of explanation. It's a placeholder we use when the real cause is unknown. And science isn't supposed to hide behind placeholders. It's supposed to break them open. Now, let's talk about the next layer of this problem, which makes the situation even more extraordinary. Jupiter isn't just any planet. It's the largest gravitational anchor in our solar system aside from the Sun. Its influence extends so far and so powerfully that it acts as both a shield and a gatekeeper for Earth. It absorbs or redirects countless objects that might otherwise strike the inner planets. It shapes the architecture of the asteroid belt. It sculpts the incoming flow of comets from the outer reaches of the solar system. If you wanted to study a solar system, not just pass through it, Jupiter is the single most important object to examine. Its magnetic field is 20,000 times stronger than Earth's. Its radiation belts dwarf anything we can produce artificially. Its gravitational influence is so powerful that it creates Trojan asteroids, entire families of objects that orbit the Sun in lockstep with Jupiter like cosmic bodyguards. So when an interstellar object approaches Jupiter with this much accuracy, it isn't just unusual, it's significant. Whether this significance is natural or intentional is the question that divides scientists. But the significance itself is not in doubt. Now, let's step back for a moment and ask a broader question, one that doesn't rely on speculation at all, just logic. If 3I Atlas were simply a random chunk of ice and rock, shaped by the usual processes of interstellar drift, gravity, and thermal outgassing, what are the odds that it would follow a trajectory measurable to 8 decimal places, undergo acceleration of the exact magnitude needed, at the exact moment needed, in the exact direction needed, to reach the exact boundary where Jupiter's gravity becomes dominant? The mathematics tells us the answer. The odds are not zero, but they are not friendly. They sit firmly in the realm of improbability, and improbability is where science gets interesting. Because when improbable events happen, they leave signatures patterns in the data that reveal what forces were involved. So now we have to talk about the signatures 3I Atlas has been leaving behind. Let's start with something NASA did confirm openly. 3I Atlas is not behaving like the typical interstellar objects we've observed before. Oumuamua, the first known interstellar visitor, didn't have a coma. It didn't produce visible outgassing. It accelerated without detectable jets. Borisov, the second interstellar visitor, did look like a comet, but with chemical signatures that didn't match typical solar system comets. 3I Atlas is different from both, and that alone makes it important. But here is the part of the briefing that NASA moved past quickly, too quickly, according to critics. The coma brightness of 3I Atlas increased in a pattern that can't be explained solely by its distance from the Sun. It brightened faster than expected, then dimmed more slowly than expected, then brightened again in a way that did not align perfectly with standard models. This doesn't prove intelligence, but it does suggest that something about its composition or structure is anomalous. Now, let's tie this back to the trajectory. Non-gravitational acceleration requires jets. Jets require vents. Vents require heat and internal pressure. This is normal for a comet, but what isn't normal is for the jets to behave like thrusters, with timing that produces gravitationally meaningful outcomes.